This video looks at the unit circle. Now, to begin with, the unit circle is radius 1, centered at 0, 0. So if we're thinking of that, this coordinate here, which has a 1, as a coordinate would be 1, 0. This point here as a coordinate would be 0, 1. This point here would be -1, 0. And the coordinate down the bottom would be 0, -1. If I have an angle theta, if I go up to 0, 1, that theta is pi on 2. Go around to -1, 0, my theta is pi. Go around again to 0, -1, and my theta is 3 pi on 2. Go back to the beginning, and my theta is 2 pi, one revolution of the circle. Now on my circle I have a point xy, which is point in reference to the angle theta. Now if I look at this triangle that's formed, that's a right angled triangle, this distance here would be x because it's a point xy, and this distance here would be y. So if I think about my trigonometric ratios, opposite the angle is opposite the right angle is my hypotenuse, and the other side is my adjacent. The other thing we know, because it's a unit circle, is that the radius of the circle is 1. So let's look at our trigonometric ratio. Sine theta is opposite over hypotenuse. My opposite is my y over my hypotenuse, which is 1, so that's just y. Cos theta is adjacent over hypotenuse. Adjacent is x, and my hypotenuse is 1, so it's x. Tan theta is opposite over adjacent, so that would be y over x. So therefore my y coordinate is given by sine theta. So if I know the value of theta, I can work out what my y coordinate is. My x coordinate is given by cos theta, and interestingly tan theta, which is y over x, is sine theta over cos theta. So this point theta can be written as cos theta sine theta. Okay, so what else can we say now knowing this? Well, in my first quadrant, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we go in an anti-clockwise direction. So in quadrant 1, my x coordinate is positive and my y coordinate is positive. So that means sine theta is going to be positive, cos theta is going to be positive, and tan theta is going to be positive. All the ratios are positive in that first quadrant. In my second quadrant here, my x coordinate will always be negative. So x is negative, but my y coordinate will be positive. So my second quadrant, sine theta, which is y, is going to be positive. Cos theta, which is x, is going to be negative, and tan theta, which is positive, which is sine theta over cos theta, is going to be positive divided by negative, which is negative. So in my second quadrant, only sine is positive. Let's go to our third quadrant. Third quadrant, x is negative and y is negative. So that means my sine theta is going to be negative, my cos theta is going to be negative, and tan theta, which is sine theta over cos theta, negative divided by negative is a positive. So in my third quadrant, tan is positive. In my fourth quadrant, x is positive and y is negative. So sine theta is going to be negative. Cos theta is going to be positive, and my tan theta, which is sine over cos, is going to be a negative. So my fourth quadrant, the ratio that is positive is cos. So first quadrant, all are positive. Second quadrant, sine is positive. Third quadrant, my tan ratio is going to be positive. And in my fourth quadrant, my cos ratio is going to be positive. Okay. Now, another point to note is that if I start at this point here on my unit circle and I go all the way around one whole revolution, so 2 pi, I end up at the same point or the same angle. Okay, so as I've got down the bottom, adding 2 pi to the angle results in a return to the same point on the unit circle. Another thing that we do with the unit circle is we always deal with the reference angle that is in the first quadrant. Okay, so if I'm in my second quadrant, I'm still dealing with that same reference angle. So this angle here would be my theta, but to go from here all the way around would be pi minus theta. Similarly, if I think about my third quadrant, where that's theta, to get from here all the way around to there would be pi plus theta. Finally, in my fourth quadrant, if I start here and go all the way around to where theta would be, drawing my triangle, there's my reference angle theta. So what we do in this case is we go, well, it's 2 pi minus theta. Okay. Finally, angles going in the anti-clockwise direction are positive. So if we're going from here that way, they're positive angles. If we're going from here down, they're negative angles. So this slide here summarizes all of that. Angles formed moving anti-clockwise around the circumference of a circle are defined as positive. Angles formed by moving clockwise around the circumference of the unit circle are negative. All angles are expressed in terms of the acute angle between the x-axis and the angle ray. So that's that theta there, or our reference angle. So we always look at that angle there. And as you can see in this diagram, this point here would be pi minus theta. Okay, so all the way around to pi and back theta. The next point in our third quadrant would be pi plus theta. And in our fourth quadrant, it's 2 pi minus theta. The other thing that's really important are these coordinates. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And remembering that our y is sine theta and our x is cos theta. So if you look up this box in pink, in our first quadrant, if we've got cos theta, sine theta, they're both positive. Tan theta is sine theta over cos theta, so it too is going to be positive. In our second quadrant, cos is negative, sine is positive, so our tan theta is going to be negative. Third quadrant, cos is negative, remembering it's our y coordinate. Sine is also negative, so our tan theta is going to be positive because a negative divided by a negative is a positive. Fourth quadrant, our x coordinate in our fourth quadrant will always be positive, so our cos theta is positive. Our y coordinate will always be negative, so sine theta is a negative. And tan theta, because you go negative divided by positive, has to be a negative. And that information summarized in these two diagrams down the bottom, which you'll use quite a lot. Okay, first theta, second pi minus theta, third pi plus theta, fourth 2 pi minus theta, and our ASTC rule, which means all ratios are positive in the first quadrant, sine is positive in the second, tan is positive in the third, and cos is positive in the fourth. So let's look at some examples using this information. First, it says, without using a calculator, state whether the following values are positive or negative. So what we're going to use here is our ASTC rule and also the theta, pi minus theta, pi plus theta, 2 pi minus theta. So if you think of pi on 4, that is less than pi on 2. Okay, so we're in our first quadrant. We know that sine is positive in our first quadrant, so that's going to be positive. Okay, if I need to add it to this diagram, remember we have 0, 2 pi, pi on 2, pi, 3 pi on 2. So let's look at part B, cos of 3 pi on 4. Now we could rewrite that as cos 4 pi on 4 minus pi on 4. Now the key is we always want this first angle to be either in pi or 2 pi, because what you'll end up with is cos of pi, 4 pi on 4 is pi, minus pi on 4. Pi minus theta is our second quadrant. So we know we're in our second quadrant, and in our second quadrant only sine is positive, so cos is negative. So this is exactly the same as negative cos of pi on 4, going back to that reference angle in our first quadrant. So we are negative. The third one here, sine of negative pi on 4, means that we're starting here and we're going backwards. So we're in our fourth quadrant. The only thing positive, the only ratio positive in our fourth quadrant is cos. So we know sine is going to be negative. So this is exactly the same as negative sine of pi on 4. So the answer is negative. The final one, we have tan of negative 5 pi on 4. So that's equal to tan. And what we do here is we go negative 4 pi on 4, and we take away another pi on 4. So that's negative 5 pi on 4. So that becomes tan of negative pi minus pi on 4. Now, if you think about what's happening here, we're going in the negative direction to pi, and then we're going in the negative direction again, another pi on 4. So we're in our second quadrant. In our second quadrant, the only ratio positive is sine. So tan is going to be negative. So this is going to be negative tan of pi on 4. So my answer will be negative. Now let's try and evaluate. Again, I'm going to draw that little diagram. All ratios, sine, tan, cos, theta, pi minus theta, pi plus theta, 2 pi minus theta. Also 0, pi on 2, pi, 3 pi on 2, and 2 pi. Okay. The other thing to remember are our coordinates. If we're thinking about our unit circle, this is 1, 0, 0, 1, negative 1, 0, 0, negative 1, and remembering that x is cos theta and y is sine theta. So let's come to this. Sine of pi. Pi means we're here at that negative 1, 0. Sine is my y coordinate. My y coordinate is 0. Cos of negative pi on 2. Actually, I'll draw a diagram here. So we've gone all the way around to that point there, and we know that coordinate is negative 1, 0, and sine is my y coordinate. In the next one, we've got negative pi on 2. So we're at this point here. That's my 0, negative 1. Cos is our x coordinate. So my answer is 0. Sine of negative 3 pi on 2. In the negative direction, we are up here. So that is 0, 1. Sine is our y coordinate. So my answer is 1. Sine 5 pi on 2. We have to play with this a little bit. It'll be sine of 4 pi on 2 plus pi on 2. That's sine of 2 pi plus pi on 2. So we're going all the way around to 1 revolution up to pi on 2. So because we've gone around 1 whole revolution, we can say this is the same as sine of pi on 2. Well, at this point here, that's the coordinate 0, 1. Sine is our y coordinate, so my answer is 1. Sine 9 pi on 2. We can rewrite it as sine of 8 pi on 2 plus pi on 2. That's sine of 4 pi plus pi on 2. 4 pi is 2 revolutions. So this is the same as sine of pi on 2 because we're going around once, twice, and then we're ending back at pi on 2. That's 0, 1. Sine is our y coordinate, so it is equal to 1. Next one, we have sine 7 pi on 2. You go 8 pi on 2, do not go to 6 pi on 2 because you need multiples of pi or 2 pi. So 8 pi on 2 minus pi on 2, that becomes sine of 4 pi minus pi on 2. That's 2 revolutions, so we can rewrite it as sine of negative pi on 2. Just to show that, we're going around once, going around twice. Then we have negative pi on 2, so we're going back in the negative direction. So we're here, which is 0, negative 1. Sine is our y coordinate, so my answer is negative 1. Finally, if sine of x is 0.93, determine the value of sine of pi plus x. Okay, remembering in terms of our reference angle, theta, pi minus theta, pi plus theta, 2 pi minus theta, all sine, tan, cos. So pi plus theta or pi plus x, we are in our third quadrant, which means sine is negative. So I can rewrite this as negative sine of x. Sine of x is 0.93, so negative sine of x is negative 0.93. In the next one, we've got pi minus x. So we're in the second quadrant. where sine is positive. So we can rewrite that as just sine of x, which is 0.93. The next one, 2 pi minus x, we're in our fourth quadrant. Sine is negative, so this is negative sine of x, which is negative 0.93. Finally, just negative x. We're going in the negative direction, so we're in our fourth quadrant. Sine is negative, so it's negative sine of x, which is negative 0.93. So you'll see this diagram here, extremely important. The other one to remember is just our unit circle and what your coordinates are. So 1, 0, 0, 1, negative 1, 0, 0, negative 1, and our angles 0, 2 pi, pi on 2, pi, and 3 pi on 2.